This is the second video for the Control101 toolbox, which is focused on state space methods. It's well known that state space methods are very powerful tools for the analysis and design of system behaviors and control, and consequently it makes sense for the Control101 toolbox to have a dedicated section on state space models, and this video series is basically to support that. This particular video focuses on how MATLAB stores a state space model and the equivalence between different model types. A reminder then, how do you find the files? So you open the tab with all the interface by typing Control101, and then you'll see, if you go to the third tab, which is state space methods, there are a number of buttons with different file names. This particular video is going to focus primarily on the buttons on the top row, which are the introductory files. Summary of the resources this video will look at then. So state space models. Then how do you get a transfer function model from a state space model, and vice versa? How do you get a state space model from a transfer function model? The equivalent between different state space formulations. And finally, a bit more focus on discrete time state space models. Now, the first model, which is state space models _ Control101, covers these topics here, but I'm not going to talk about that more because it'll be more efficient to do a live demonstration rather than describing the files in abstract. So first, we demonstrate the key point. Once you've opened this tab here, I can just press on one of these buttons and the relevant file will open. So here we've got this file, state space models _ Control101. So I'm not going to do this particularly slowly, but you can see roughly how the file is set out. First of all, a basic introduction to what a state space model is. How do you start from differential equations and then break them down and eventually put them into state space format. And so there's a number of different examples, and the key thing is showing how do I store these in MATLAB. And you can see here's the key statement here, and you can see the model appearing on the right hand side. So that's the key purpose of this file. How do I get these state space models into a format that MATLAB can use? And then you'll see at the bottom what happens if the system's discrete time. Well, you can see some discrete time examples given here, and it shows you how the command changes in order for MATLAB to know it's discrete. So you'll look over here on the right, can you see MATLAB recognizes that the model is discrete because of how you created it. So that's the first file. Okay, second file. Apologize, that should have been the top. How do I get a state space model from a transfer function? So basically, you'll see there's a bit of background again, a bit of theory, because it often helps to have a little bit of theory first to make yourself comfortable. And actually we're starting here with differential equations and showing the link between differential equations and state space models. Then we look at the equivalence between differential equation models and transfer function models, which again is just background. We've not got to MATLAB yet. But then we move on to, okay, let's assume you've got this transfer function model. Here's one. How do I find an equivalent state space model? And you can see the code is given here and the solution appears on the right hand side. So there's several examples that you can use, and also at the bottom some examples of what if the system is in discrete time. Okay, what if we want to go the other way? What if we've got a state space model and we want to create a transfer function model? Well, again, you'll see that this file goes through the process and basically shows you how you can use the definition of Laplace to find a relationship between your state space model and a transfer function model. So there's your sort of theoretical background done concisely, and then we move on to how do we do this in MATLAB, and you can see the key statement is here, and there's a number of different case studies for you to play with. And once again, as we go down, you'll see there's also some examples done in discrete time. Equivalent formulations then. What will become clear is that you can have what appear to be very different ABCD matrices, but they're actually the same system. So this gives you a little bit of background on when our two state space models, for example these two here, in effect modeling the same system but just with a different choice of states. And the theory is there, and then you can see a number of examples down here where you're given different A, B, C, D, and yet what you see on the right hand side is the behavior is the same. Essentially, they're giving the same behavior. So this code basically shows you how you can do equivalences and how you can do this on MATLAB. There's also what transformations will allow you to get canonical forms. Canonical forms can be quite useful because they give guarantees of observability or controllability. So you might want to get to a canonical form. And again, this shows you how you can use MATLAB to find transformations which will then get you into an appropriate canonical form. So again, you'll see lots of examples all down here so that you can replicate. And finally, a little bit of focus very specifically on discrete time. So what's the relationship between a discrete time system and a continuous time system? So again, you'll see a bit of theoretical background showing how the continuous time and the discrete time system are related, and then some code basically showing you how you can get the discrete model parameters from the continuous model parameters. So just a couple of examples because it's relatively straightforward. So in summary, this short video has given a quick review of the introductory resources to support the study of state space systems. The files can be accessed most conveniently through the shortcut interface tab, as shown here on the right. And these resources focus on the definition of a state space model within MATLAB and how to establish equivalences between different formats, including discrete time.